Have you ever actually stopped to think about what happens inside that machine sitting right in front of you? We interact with computers constantly, almost instinctively, really. Yet the complex dance between the physical machine and the invisible data powering it, well, that often remains a total mystery. So today, we're going to break down the anatomy of a computer and map out the fascinating journey that data takes to power our daily lives. Okay, let's dive into the core question that's going to drive our entire explainer today. How exactly does a thought, a keystroke, or a click transform into meaningful action inside a machine? To really understand this, we have to look at the computer not just as a single solid object, but as a complex biological system made of highly specialized parts working in perfect harmony. First things first, we've got to establish the ultimate rule of this system by drawing a very clear line between its two fundamental halves. On one side, we have hardware. Think of this as the physical body of the computer, the parts you can literally touch and feel, like your desk or your mouse. And on the flip side, we have software. This is the invisible mind, the untouchable set of instructions that tells the physical body exactly what to do. You simply cannot have one without the other. So, here is the blueprint for our journey today. First, the physical realm. Second, getting data in. Third, the brain. Fourth, seeing results. And finally, number 5, the invisible conductor. Let's kick things off with Section 1, the physical realm. Let's formally define hardware. It's simple, really. Hardware is the physical part of the computer that you can touch, feel, and see. What's kind of fascinating about this definition is just how broad it is. Even non-computer items like a pencil, an eraser, or the book in your hand, they perfectly fit this physical definition of hardware. If it occupies physical space and you can grab it, it's hardware. But for a computer to actually be useful, this physical hardware needs to interact with the outside world. Which brings us to Section 2, getting data in. Think of input devices as the eyes, ears, and fingertips of our machine, and we've got an incredible variety here. We have typing and pointing tools, ranging from your standard mouse to a complex gaming joystick. Then we have scanning and visual tools, like webcams, or think of a salesperson scanning your groceries at the mall with a barcode reader. Finally, we have touch and draw devices, things like graphics tablets for artists, or even light pens that let you write directly on a screen. Every single one of these exists for one purpose: to feed raw data into the machine. Take the most common input device of all, the classic QWERTY keyboard. Originally designed to keep mechanical typewriter keys from jamming, it's actually neatly divided into 4 specific zones of control. You've got your typing keys for alphabet and numeric input, function keys running across the top for quick shortcuts, navigation keys to move around your documents, and control keys like Shift and Alt that modify how other keys behave. It's a highly optimized control panel specifically built for human intent. Moving on to Section 3, the brain. All right, so your data has successfully entered the physical realm through one of those input devices. But now we have to ask, where does it go to be thought about, calculated, and remembered? Well, hidden safely inside its casing is the CPU, or Central Processing Unit. This is the literal brain of the computer. This is where the absolutely crucial processing phase happens. Raw, unorganized data comes in, and the CPU actively transforms it into useful, meaningful information. It's the difference between you just pressing the number 2 on your keyboard and the computer actually understanding that you want to calculate a math problem. And this digital brain is comprised of 3 distinct parts, all working seamlessly together to form a complete, functioning mind. First, you have the ALU, or Arithmetic Logic Unit, which crunches all the hard mathematical and logical calculations. Then you have the CU, the Control Unit, which manages and directs all the operations happening within the machine. And finally, the MU, the Memory Unit, which holds onto the information while the brain is actively working on it. But where does the brain keep its long-term memories once the active thinking is totally done? We have to distinguish between main and portable storage here. The hard disk acts as the main internal vault where the computer stores its core information, but we also have portable storage, things like pen drives, CDs, and Blu-ray discs. These allow us to take those memories out of one brain and physically transport them to another for future access. Now for Section 4, seeing results. Okay, so the brain has processed the data and stored the memories. Now the computer needs a way to express its results back to us in the outside world. When it communicates, we divide its expressions into 2 primary categories based on permanence. We have the soft copy, which is the transient, fluid visual output displayed right there on your monitor screen. And then we have the hard copy, where the computer's thoughts are made physically tangible, permanently printed out onto paper. Just like the computer has various senses to take data in, it needs a voice to speak back to us, and we group these as output devices. Visual outputs include your standard flat-screen monitors or projectors, illuminating meeting presentations. Audio outputs give the computer a literal voice through speakers or personal headphones. And print outputs range from everyday inkjet printers to massive plotters, used to produce high-quality desktop publishing designs. Finally, Section 5, the invisible conductor. So here's the catch. We've built an incredible physical machine up to this point, but it's essentially asleep without an invisible mind directing it. And this brings us to software. Software is a set of instructions given to the computer to perform a given task that cannot be touched, felt, or sensed. It encompasses everything from the simplest notepad program to the most complex operating systems in the world. Software provides the rules of engagement. Without it, your CPU is just a piece of silicon and your monitor is just dark glass. To truly understand this invisible conductor, we can view software in 3 distinct ascending layers. Each layer builds directly upon the last, moving from the most foundational operations governing the hardware straight up to the sophisticated tools used by human coders to write the future. Step 1 is system software. This is the absolute bedrock layer. It wakes the hardware up and essentially breathes life into the machine. Operating systems like Windows or Linux live right here. They work silently in the background, making sure the keyboard talks to the CPU and the CPU talks to the monitor, allowing the transfer of data from input to output without you ever having to manually manage those connections yourself. Step 2 is application software. And this is the highly interactive middle layer where you and I spend most of our time. When you want to type a document, edit a photo, or just browse the web, you use application software. Programs like Microsoft Office or Photoshop sit right on top of the operating system to help you get your specific, daily, user-friendly work done. And finally, we reach the top layer, programming software. This is the domain of the creators. These are the specialized languages like Python, C++, Java, or even educational languages like Logo that human beings use to build all the other software. It's literally the language we use to translate human intention into machine action. So it all comes back to a perfect symbiotic relationship. Hardware can be anything which can be touched, felt, or sensed. Software is the component that cannot be touched or sensed. The tangible body requires the untouchable mind, and the untouchable mind requires the tangible body to actually express itself. It's honestly a quiet miracle of modern engineering, and it's happening on your desk right now. So the next time you casually click your mouse or tap your touchscreen, I want you to ask yourself, what invisible, lightning-fast journey did your data just take? What inputs fired? What CPU processes calculated? And what software governed the exact moment that hard copy or soft copy appeared before your eyes? Thank you so much for joining me on this explainer. Keep wondering and keep learning.